to the gym. Thank you.
Great time for that announcement to start in, right? Fantastic. All right, so today what we're going to do is we're going to go look at how do you use the periodic table to do electron configurations instead of using that diagonal rule. So a lot of folks have seen the periodic table before, and you've seen it, it looks like this, and people always freak out about it. They're like, 1's over here, then 2's over there, 3, 4, and then there's a gap to 5. Why is the table laid out like this? And now you actually have enough information that you can qualify that, right? You can figure this out. So to do that, what we're going to do, a little text box up there, what we're going to do is we're going to color this in. And the way you color this in is we're going to insert a rectangle, and we're going to make sure that rectangle is filled in all the way. And then transparency-wise, we're actually going to make that rectangle fairly transparent. It starts off up here at the top. You click the circle and you drag it all the way down to make a nice transparent rectangle. And my first rectangle here is going to be this bluish color. And I'm going to fill in this part right here. There is a block on the table that sits right there, right? You can very clearly see it's kind of blocked off. There's a little hole in that block. We'll talk about that in just a minute. The next block on the periodic table I'm going to make red. I'm going to jump over to this block right over here. Makes sense, right? There's one on the left, one on the right. And then there's a block here in the middle. Go big orange. And finally, there's a block down here at the bottom. If you're like me, that orange and that green look very similar in color, but I have to use it. I guess you could put black or gray down there. But anyways, yeah, so there are like 4 blocks on the periodic table. And thinking about what we've been talking about the last couple of days, it should make sense to you to start thinking about the fact that there are those 4 named sublevels, right? The S, the P, the D, and the F. And so these blocks actually have to do with those sublevels. So let's start first. Let's look at this first block right here. The first block, oh, you know what? It says here I can move it over to the right. Oh, that's fantastic. Let's do that. All right, so this first block was blue. So let's go in here and let's label this first block. Obviously, it has 2 columns, right? 2 columns. Hey, one of those sublevels fits 2 electrons. Aha! This corresponds to the S sublevel. So that block is it's often called the S block because it corresponds to the S sublevel. Well, if I know that 2 columns makes the S sublevel, then 6 columns has to be the P sublevel. And looky there, over on the right-hand side, there are 3 columns. That is the P sublevel, right? And while I'm here, I'm going to look at this square right here. I'm going to notice, hey, that square is kind of out of place. That square belongs to helium. Helium is not on the P sublevel block. It actually belongs back in here. So what we're going to do is we can go ahead and shade it in, hopefully the same color of blue, to show that it belongs over here. Oops. Let's get rid of this. Boom. Fantastic. All right. So now what we're going to do is we're going to label that middle block, right? Notice there are 10 columns in that middle block. So this one must be the D block because the D block has 10 electrons in it, maximum. And then down at the bottom, our last one here, I guess I have to put this one green, right? Is that right? I don't know if I'm on the right colors, folks. I'm sorry. I'm colorblind. I'm not ashamed of it. F block goes down here at the bottom. So D block there, S block, P block. Oh, let's label them all the same way, right? I put block in there on accident. This one is the D sublevel. This one is the F sublevel. All right. So now what we're going to do is when we were doing electron configurations, right, we were alphaing, we were building up. So we're going to do the same thing here. We're going to be able to build up to a certain atom on the periodic table to a certain element on the periodic table. And in so doing, we are going to create the electron configuration for that element. So if we look down here, let's say, for example, we wanted to go to magnesium, right? To build up to magnesium, you got to start with element 1, then go to element 2, element 3, element 4, element 5, 6, 7, 8, 9, 10, 11, 12, right? And that's exactly how we're going to do this up here on the periodic table. But to do that, we need to know what electron configurations are in each of these squares. So to do that, we're obviously going to look at a block, and we're going to look at this S sublevel right here, and we're going to try and figure out what I'm going to, by the way, need to change your ink color back to black here. We're going to write something on top of these. We need to figure out what each of these blocks is going to be. I know this ends in an S. I know this ends in an S. I know that ends in an S. But the key is to figure out what S these guys end in. And it's pretty simple. In the first one, you always start in the when you're drawing the diagonal rule, the first thing you always draw is always 1S, right? So that first element is going to be 1S. The next element, which I could write over here, or I could write right here. I'm going to write it right here just to keep things simple, is also 1S, all right? And that gives me two 1S's. How many electrons can you fit in 1S? You can fit 2. So there they both are. These are the two 1S's that you can get. They are hydrogen and helium. Those electrons also correspond to elements on the periodic table. I'll show you a little bit more about that here in just a second. After 1S, the next element is element number 3, which is this block right here. Right? It's this block right here. It's lithium. So what does lithium have to end with? Well, lithium has to, it's still in the S block, but now we filled up 1S, so we go to the next row is going to be 2S. So that one's a 2S, and the next one's a 2S. It's kind of neat. Okay. All right. So now after 2S, we go to this block over here, right? Elements 1, 2, 3, 4, 5. All right. I don't want to deal with the P block just yet. We'll get to that one. Okay. But I want to see if anybody can pick up the pattern here. If you look, there's a pattern. What does the next block, next set of blocks, these two blocks right here, what do they have to be? They've got to be 3S. And after 3S comes 4S. After 4S comes 5S. And so on and so forth. I'm not going to fill them all out in this video, because that would take way too freaking long, okay? Oops, the next one is 7S. In fact, especially if you make mistakes like that. But eventually what's going to happen is towards the end of this video, I'm going to stop it, I'm going to pause it, and then I'm going to fill in the rest of them, and then come back and hopefully wrap things up for you. All right, so what do we need to do now? Now let's go look at the P block, okay? So like I already said, we go from element 1 to element 2 to element 3 to element 4. The next thing after 4 is 5, right? That's element number 5. So we go 1, 2, 3, 4, 5. There's element number 5. That's boron. It's the first one in the P block. Notice it comes after 2S. So if you look at your diagonal rule, what is the next thing filled up after 2S? It's 2P. So this is not 1P, because remember, that one's not allowed. This one starts off with 2P. And everything in this row is going to be 2P, right? And then we go down the column here, and just like before, this next one's going to be 3P, and we're going to have 4P, etc., all the way down, so we can fill out the P block. All right, now the D block. If we go and we look at the D block, all right, we have a 4S here and a 4S there, right? This row, they're always the same. So here we have a 4S. Now after 4S, right, so that element is element number 20. It is a 4S element. And by the way, you'll notice on the real periodic table, look, there's a 4. We're in the S block, so it's real easy to find that this is 4S, all right? What do we go to after 4S? A lot of people are going to be like, well, now we're in the D block. That's 4D. You're wrong, right? We don't go from 4S to 4D. Look at the diagonal rule again. In the diagonal rule, you go from 4S to 3D. So in the D block, we have to remove 1 from that row number to get, or some folks just memorize that this first one is 3D. Oops. Let's move it. There we go. 3D. That means everything in this row is 3D. All right. And everything in the row below it is 4D. Everything in the row below that is 5D, etc., etc., etc. We can get a 6D in there. And while I'm at it, let's finish up with the F block. All right, for the F block, we need to figure out what element that is. So let's scroll on down. That's element number 57. It's lanthanum. Interesting side note for you. We're going to talk about this next week. This whole series is called the lanthanide series in its honor. Element number 57 comes after element number 56. So we need to know what element number 56 is to see what element number 57 is going to be. So element number 56 is right here. It's 6s. After 6s, you jump down here to the F block. The next thing after 6s, if you look at your diagonal rule, is 4f. So again, some folks memorize the fact that this one is 4f. And some folks just memorize the fact that what row we're in here, and they do some math to figure that one out. Whichever way, as long as you get the pattern, that's the important part. All right, I'm going to pause my video right here, and then I'm going to fill in the rest of this chart. All right, now it looks pretty good. The only problem I've got is, number one, I've got that blue box just all by itself. I want you to remember, I'm going to draw a little arrow here, that we remember that that element actually belongs over here. And down here at the bottom, when I was doing this, I counted out 14 4Fs and 14 5Fs. And there's this extra column in there. This is one problem with a lot of periodic tables that I've seen. They put an extra column down here at the bottom. Don't like that at all. By the way, that's why I made my own periodic table. There's only 14 columns down here at the bottom of my periodic table, because there should only be 14 columns in the F sublevel block. So yeah, that's kind of neat. So how do I use this? How do I, as a chemistry student, use this in order to do, for example, let's say we have a question that asks me, if I am looking at element number 45, which element number 45 is rhodium, RH. Let's say I need to find the electron configuration of that atom, okay? So element number 45, I'm going to look, rhodium is right here. It's in the 1, 2, 3, 4, 5, 6, 7th column and the second row of the D block. So it is right here. I'm going to draw me a circle showing this is where I want to go. So 1, 2, 3, 4, 5, 6, 7, second row, it's going to be this block right here. So that's where I want to wind up at the end of all of this, all right? What am I going to do? I am going to Aufbau. I am going to practice my German, but I am also going to build up, right? So to build up to there, that's where we want to end. We've got to start somewhere, and you always start in the same spot. It's right here. So we're going to start with element number 1, which is 1s. And then we're going to have element number 2, which is also a 1s. Well, since I've already written 2 element 1s's, I feel like that's a lot of writing, right? I got to be able to compress this some way. Especially, you imagine when we get down here into the D block, we might have 10 of these things. So we're going to take a little shortcut, and our shortcut is what we've already seen. 1s2 tells me that there were 2 1s elements. Haha, fantastic. Now I got to remember that now that I've gotten to the end of the row, I go down to the next row, and we start again. And the next thing that we see here is 2s. And check it out, there are 2 of them. So we're going to put a number 2 on that one as well. Now notice the row doesn't end here. So you got to go all the way over and across to the 2p. And how many 2p's are there? 1, 2, 3, 4, 5, 6. 2p to the 6th. Now we go to the next row. We get 3s. And there are 2 3s's. So it's 3s2. And then we go across the row. We go from 3s over to 3p. So here we got 3p. And that is 3p6. 1, 2, 3, 4, 5, 6. Check. Next up is 4s. Check. And there are 2 of those. Then we get to 3d. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 3ds. Oh my goodness. We'll try not to have a fit over that. 10 of them, I can't believe that. 3D, after 3D is 4P. So there are 1, 2, 3, 4, 5, 6, 4 Ps. And then after 4P, we go down back to the next row, and that is 5S. And there are 2 5S's. All right, Now we get to the block and the row where our element is. So we are only going to count up to that element. 1, 2, 3, 4, 5, 6, 7. There are 7 4Ds, so we're going to write that as 4D 7. And that's how you do an electron configuration using the table.